In this video, we're going to learn about the law of sines, which allows us to solve a triangle that's not a right triangle. Anytime that we know at least two angles and a side, or we know two sides and an angle opposite of one of those sides, the law of sines will allow us to solve the triangle. So let's just start by saying what the law of sines is and get to some examples. The law of sines says that if triangle ABC is a triangle with sides little a, little b, and little c, opposite angles capital A, capital B, and capital C, respectively, then A over sine of A equals B over sine of B, which equals C over sine of C. And we can also do the ratios upside down and put sine of A over A, sine of B over B, and sine of C over C. It works that way as well. So let's do some examples using this law of sines. So let's solve triangle ABC with angle B equals 70 degrees, angle C equals 48 degrees, and side B is 15 centimeters. We're going to do everything to one decimal place. So I like to draw a sketch of the triangle just to help organize my thoughts, and the sketch does not have to be perfectly accurate. So I'm just going to draw a random triangle here, and it's not going to be perfectly to scale. So here, angle A, B, and C. My sides are A, B, and C, the sides opposite of the angles with the same letter. Now I'm going to fill in the information that I know. Angle B is 70 degrees. Angle C is 48 degrees. And I know angle B, or not angle, side B is 15 centimeters. And now let's figure out everything else that we need, which is side A, side C, and angle A, using our law of sines and other things that we already know. For instance, I'm going to find angle A by using the fact that there are 180 degrees inside of a triangle. So I have 180 degrees minus 70 degrees minus 48 degrees is equal to my angle A. So angle A is 62 degrees. So now to finish solving the triangle, I just need to find side A and side C using my law of sines. Now, my law of sines tells me that little b over sine of angle B should be equal to my little, little a over my sine of A. So let's fill in all of the info that we know from this. I know little b is 15, sine of B would be sine of 70 degrees, and now I know that my angle A is 62 degrees, so I can fill that in and solve that for little a. So I have 15 over sine of 70 degrees is equal to little a over sine of 62 degrees. So this means that little a is equal to 15 times sine of 62 degrees divided by sine of 70 degrees. And if I type that into my calculator and round to one decimal place, I get that A is approximately 14.1 centimeters. Now I'm going to do the same thing to find side C. I know that B, 15, over sine of B, sine of 70 degrees, should be equal to C over sine of C, which is 48 degrees. This tells me that the side C is equal to 15 times sine of 48 degrees divided by sine of 70 degrees. Typing that into my calculator and rounding to one decimal place, I get 11.9 centimeters is approximately equal to my side C. And now we found everything we needed to finish solving the triangle. Let's do another example. Solve triangle ABC with angle A equals 33 degrees, angle B equals 112 degrees, and side C equals 16 to one decimal place. And again, I'm going to draw a picture to represent this triangle. There's A, B, and C, and my sides opposite the angles, A, B, C. Fill in the info that I know. Angle A is 33 degrees, angle B is 112 degrees, and side C is 16. Let's start by finding angle C. Angle C is, again, 180 degrees minus my other two angles. So minus 33 degrees and minus 112 degrees. So angle C is equal to 35 degrees. And now I can find sides A and B using angle C and side C. I know that my C over sine of C should be equal to A over sine of A. Filling in the information that I know, I have 16 over sine of 35 degrees is equal to little a over sine of 33 degrees. And then I can solve for little a by multiplying by that sine of 33 degrees and getting 16 times sine of 33 degrees over sine of 35 degrees is equal to a. Typing that in and rounding to one decimal place, I get 15.2 is approximately side A. So now I found angle C. Let me just fill it in so I don't forget it, 35 degrees. We just found side A is about 15.2. All I have left to solve for is side B. So using my law of sines again, I know that C over sine of C is equal to B over sine of B. So I have 16 over sine of 35 degrees is equal to B over sine of 112 degrees. So 16 times sine of 112 degrees over sine of 35 degrees is equal to side B. Rounding to one decimal place, I get 25.9 is approximately side B. And there we go, we solved the whole triangle. And notice that the largest side is opposite the largest angle, and my smallest side is opposite the smallest angle. That's going to happen every single time we solve a triangle. So this works out pretty nicely when we are given two angles and a side. But in the case where we have two sides and an angle opposite one of those sides, sometimes we find out that there is a unique solution. Sometimes there's two different solutions, and sometimes there's no solution at all. So in order to figure out what's going to happen on those, you just have to keep in mind that we need to check to make sure that this is something that legitimately can occur. So let's just go ahead and do some examples. We're going to have an example where we get exactly one solution, one where we have no solution, and one where we have two solutions, just to show you all the possibilities. So let's solve triangle ABC with angle A equals 49 degrees, side A equals 32, and side B equals 28. So we have two sides and one angle, and an angle is opposite one of our sides that we're given. So here's triangle ABC. Label the sides opposite the angles. I have angle A is 49 degrees. I have this A is 32, little b is 28. So if I'm going to try to find everything else in this triangle, I know that I need to use all of the given information to find angle B, and then I can figure out stuff involving angle C as well. So let's start by relating all of the given information to find angle B. Using my law of sines, I know A over sine of angle A equals B over sine of angle B. So I have 32 over sine of 49 degrees equals 28 over sine of B. This tells me that sine of B is equal to 28 sine of 49 degrees divided by 32, which we could simplify if we wanted to. If you type this into the calculator right now, you will get a value of 0.66 approximately. It's important to check on these problems where you're given two sides and an angle. So it's possible that you'll end up with something over here that doesn't make sense in the sine value. When that happens, it means that there's no triangle that satisfies these conditions. However, it is possible for sine of B to be 0.66, so we can keep going. To figure out what angle B is, we just need to do an inverse sine of that result. So angle B is equal to sine inverse of my 28 sine of 49 degrees over 32. Just type that directly into the calculator and you get that angle B is approximately 41.3 degrees. Now, remember though, that when we look at our unit circle, sine is the y value. If angle B is about 41.3 degrees, we're talking about an angle around here. My sine at that value is equal to the sine of this angle over here. So we should check because that is another possibility for this angle. That angle is equal to 180 degrees minus 41.3 degrees, which is equal to 138.7 degrees. However, that particular value is not valid on this triangle. Why? Because that 138.7 degrees plus the 49 degrees that I already know is too big. It's already over 180 degrees, and we know that the angles inside a triangle can only add up to 180 degrees. So this one is not valid, but we should still check it because sometimes that does occur. But now I know angle B is about 41.3 degrees. Now I can take that information and figure out what my angle C is. angle C is equal to 180 degrees minus angle A and minus angle B. So this means angle C is equal to 89.7 degrees. And of course, my triangle that I drew is nowhere near to scale. It was just to help us organize our thoughts. Now, all that I have left to find is side C. So to find side C, I just have to use my law of sines again. C over sine C will be equal to A over sine A or equal to B over sine B. It doesn't matter which one we use. I'm just going to be using my A over sine A. So I have 32 over sine of 49 degrees equals little c over sine of 89.7 degrees. And that means that my side C can be found by multiplying both sides by sine of 89.7 degrees. So 32 times sine of 89.7 degrees divided by sine of 49 degrees is equal to side C. And to one decimal point, that is 42.4. So C is 42.4, and we've finished solving that triangle. So that's an example where we're given two sides and an angle, and there's only one unique solution when we solve the triangle using the law of sines. It is possible to have no solution, and it's also possible to have two different solutions. Let's do another example to show a different case that can come up. Let's solve triangle ABC with angle B equals 31 degrees, side B is 3, and side A is 6.2. Again, just draw a triangle to organize your thoughts. And label it with all the information that we're given. All right, so the first thing I would do is find angle A using my law of sines with the information about B and the side length A. So my law of sines tells me that my B over sine B will be equal to A over sine A. So I have 3 over sine of 31 degrees equals 6.2 over sine of A. That tells me that sine of A is equal to 6.2 times sine of 31 degrees divided by 3. Now, if I type this right side into my calculator, I find out that this is approximately 1.06 on that right side. And is it possible for sine of an angle to be equal to 1.06? No. Sine is always going to be between -1 and 1. 1.06 is too big. So this tells me that there's no triangle that satisfies this. No solution. I don't even need to bother trying to find the other sides. There is no triangle that satisfies these conditions. Let's do another example. Let's solve triangle ABC with angle A equals 40 degrees, side A equals 22, and side B equals 25 And we're going to do 1 decimal place again. So let's draw a picture just to organize our thoughts and see what we have. I have angle A is 40 degrees. My side B is 25. And side A is 22. And I don't know side C. So let's start by finding angle B. Using my law of sines, I know A over sine of A is equal to B over sine of B. So I have 22 over sine of 40 is equal to 25 over sine of B. And that tells me that sine of B is equal to 25 sine of 40 degrees all over 22. Now, if you type that right-hand side into your calculator, this time you're going to get about 0.73. That is a valid value for our sine, so we can continue and find our angle B. This tells me that angle B is equal to sine inverse of 25 sine of 40 degrees divided by 22. If you type that into your calculator, you're going to get B is approximately 46.9 degrees. But remember, again, here's my unit circle. We'll say 46.9 degrees is somewhere right around there. My sine is the y coordinate of that point. And over on this side, I have another y coordinate that is equal to that. What is that value? Well, that value is 180 degrees minus that 46.9 degrees, which is 133.1 degrees. Now, is that a possible value? If my B was 133.1, with my A being 40, they would add up to be 173.1, which is still less than 180. So it's valid because there is a possible angle for our angle C. So I have 2 possibilities for angle B this time. We're going to have 2 different triangles as a result. So let me just draw what our 2 triangles are. They're not going to be drawn to scale at all. This one I'm going to use 133.1 for my B, and this one I'm going to do 46.9 for my B. Now for both of those, we can figure out angle C based on just subtracting from 180. So in this first triangle, angle C is equal to 180 minus my angle A minus my angle B. And I get that angle C is equal to, let's see here, 93.1 degrees. On the second version, angle C is 180 degrees minus 40 degrees minus 133.1 degrees. That angle C is equal to 6.9 degrees. So those are my 2 possibilities. And then I would have to find side C using my law of sines. On the first triangle, I can do my A, which is 22, over sine of A, sine of 40 degrees, is equal to my C over sine of 93.1 degrees. That tells me that side C is equal to 22 sine of 93.1 degrees over sine of 40 degrees. when you type that into the calculator, you get that that side C is approximately 34.2. 34.2 is approximately C. And I fill that in on that triangle. Now for triangle 2, I do the same sort of thing. I have 22 over sine of 40 degrees equals C over sine of 6.9 degrees. So this side C is equal to 22 sine of 6.9 degrees over sine of 40 degrees. When I type that into my calculator, I get about 4.1. And so I have these two possible triangles fully solved. My first triangle has angles A, B, and C, 40 degrees, 46.9 degrees, 93.1 degrees. And sides ABC, 22, 25, 34.2. Triangle 2 has angles ABC, 40 degrees, 133.1 degrees, and 6.9 degrees. And sides ABC, 22, 25, 4.1. Two very different triangles, but both are valid given the information that we were given. So this shows you when you're given two sides and an angle, it is possible to have one unique solution, no solution at all, or two completely different triangles as possible solutions. Now, one of the last things that we can do using our law of sines, but manipulate it, is we can compute the area of a triangle using just two sides and an angle in between them. So computing area of a triangle with two sides and an angle between. For a triangle ABC, with sides little a, little b, and little c, opposite angles capital A, capital B, and capital C, respectively, the area is given by area equals 1/2 BC times sine of A, which equals 1/2 AB sine of C, which equals 1/2 AC sine of B. So in all of them, it's 1/2 times two sides times sine of the angle in between those sides. So let's do an example utilizing this area formula. So a triangle has sides 12 meters and 6 meters. And the angle between them is 76 degrees. Find the area. Now, I don't need to draw a picture to represent this situation, but I'm going to just to show where these formulas are coming from. So let's just call our triangle ABC like we've been doing it. A, B, C, we have sides A, B, and C. Now, it doesn't tell me which angle is all of these things, but that's okay. I'm going to say side C, I'll make that one 12. And side A will be 6, and the angle between them is 76 degrees. Doesn't matter where I set this up, as long as I have it as two sides that share an angle like that, and that angle in between is where I put that 76. Now, using my formulas, I'm going to be using the A, C, and sine of B, because that's the way I have my triangle layout. 1/2 AC sine of B. So area is 1/2 times 6 times 12 times sine of 76 degrees. 1/2 times 6 times 12 is 36. So I have 36 times sine of 76 degrees. And if I happen to type that into a calculator and round it to one decimal place, I'm going to get 34.9 square meters as the area of that triangle. So finding the area of a triangle, we normally do it as 1/2 base times height. This is the same formula, honestly, it's just translated into trigonometry so that we can use the sine of an angle to help us find the area of a triangle. That's all I have for you today. Hopefully you find the law of sines is kind of useful for finding different sides and angles of a triangle. If you have any questions, feel free to drop them below, or if you're a current student, you can also ask in email, office hours, or in class. And I'll see you guys next time.